Right. This Cisco Certified Network Associate, it's the real fundamental course. We may see multiple vendors like HP, Juniper. Juniper is soon going to be HP. Um, there are various vendors, Huawei, Zati. There are various vendors. In firewall, you have FortiGate, Palo Alto, Cisco, ASA firewall, and much more. In data center, we have many vendors, not only Cisco. There are many vendors. So, to understand all these vendors, to understand all the networking technology, one should have good fundamental, the foundation. And only Cisco gives that real foundational courses. No other vendor has got this um, neatly designed. There may be some vendors, but not popular, so we don't know. If they approach me, I'll make them popular, but no one approached. But I do see some vendors having it, some good courses to teach fundamentals. But Cisco only popular in conducting exams, certifying them. Cisco Certified Network Associate. Very important course than any other course in networking. All other big courses people talk about will come only after this. If we know this, you know that. Yeah. If you know this, you will know that. Straight away, those who go to that higher level, they don't really get the complete story. They feel that they got it, but they truly don't get it. And when someone talks about some scenarios, they will come to know, yeah, I didn't get it. Yep. So this is a wonderful course, Cisco Certified Network Associate, a very good foundational course where we are going to learn the ABC of networking. Not only that, all the grammars of networking. So grammar and alphabets are very important for a language. குரங்கு போனாங்க, யானை வந்தாங்க. Is it nice? No. ராம வந்துச்சு, கோபிநாத் போச்சு. No. Grammar is very important. Likewise. Networking grammar is found in CCNA. Right. Before we get into big stuff, let us try to understand what is networking. Networking. Making connectivity possible. Making the network, that connectivity. For what? For communication, for another, for transactions, maybe money transaction. You can call it as business. Conferencing, video, audio. See, early days, seeing a relative, if they are in the next town, we used to see once in a month or sometimes 3 months in 3 months. But nowadays, anyone can see anyone at any point of time. If they have WhatsApp, boom, they call, they can see. But early days, people who are in the very next town, we happen to see them once in 3 months or once in a month. And those who are abroad, sometimes we don't see. Before they go, they say, I'll come back, but they never come back. And to make a call also, we have to book the call. We have to book a call. And we need to compromise with the audio quality. Sometimes echoes used to come, sometimes delay used to be there. When we speak, they don't get our voice on time. All these difficulties we had. But today it's not like that. Even if you don't have internet, you have data roaming. So anywhere you go, you are able to connect to anyone. Roaming has become very easy. How these things are possible, that's what networking is. It's because of networking. Now we have in schools digital class nowadays, colleges, digital classroom. Those people who don't want to come to office during the training hours, they can watch our class live through this digital classroom. I have delivered a lot of training like that. People enrolled for training will be like 20. But when I go to that office, there will be only 5 people in the office. And there will be one big board, a digital board, and there will be a camera, 360-degree, rotating camera. Wherever I move, the camera will also move towards me. Motion control. And people at home, they don't feel that they are in home. They feel real, they are seeing me. When I move, the camera also moves. So the attention is very close, even though they are in school, in a house. How is that possible? Again, networking. Is that all about networking? No. Someone sent some photo like 10 years back. If you still have that same phone, the 10 years back phone has got those photos in it which was sent 10 years back to you. And now you can resend it to someone if you want. So, not just voice, video, we send images, we store images and we retrieve it from remote. We store all the photos in cloud. 10 years back we did not have cloud, but I'm just talking about next to 10 years. After 10 years, even when we change phones, we still have the same photos and documents from the cloud downloaded to all new phones. So networking is not just communication. We also have resource like hard disk storage shared with us from somewhere, cloud. What do we call this cloud? A big data center with big storage, big CPU, big RAM, from which a portion is given to you, where we put our data and retrieve whenever we want, where we run some application so that our CPU will not be in trouble, our local CPU. I may not have that fast CPU, I may not have that big RAM, but if I have a big cloud subscribed, I can run all my application there and get the result. To run application, I don't need to buy a server. I just buy a portion of resource from the cloud, and I'm able to run the application there and test the application. For example, you see, when we go higher and higher, like CCIE, or any big technologies that when you try to do like SD-WAN, you need very big computer. This normal 32 GB RAM and all won't be enough. But are you going to buy another big computer for that? No. We go to AWS, Azure, or some cloud service. We subscribe. We rent, we take it for rent, a portion of resource, and we do the labs there, SD-WAN labs or SD access, because they need a lot of CPUs and RAM, like 128 GB RAM to run. See, so networking in various ways improved our day-to-day life. It is not just communication. In the beginning, it was only for communication. But now it has become part of our life. That is true. Without cell phone, you don't go anywhere. Which means it became your part. Cell phone is a part of networking. And that's without cell phone, you are not going anywhere, which means you became part of networking. Everyone is now part of networking. Everyone. Whether he is one mason, construction worker, or he is a collector, or the president. They all carry one cell phone with them. They all become part of network. Networking is now everywhere. In house, in schools, colleges, hospitals, bus. Yes, in buses. In buses also we have networking. There's a QR code. You scan and you book the ticket and you get the seat number. You go and sit in the seat number. No one will come and fight for that seat. You know, there are buses like that in European countries. If the seats are full, it won't allow you to have a ticket. You won't get a ticket. When the seat is there, it allocates for you. All that you need to do is scan the QR code and say where you want to go and pay the amount. You get the seat. You go and get in and sit inside that seat. That's it. No contractor, no nothing. Right, but someone monitors you over the camera, IP camera. So again, that is another network. All right, now to do all these things that we are talking here, to do all this thing, connectivity is very important. We have various types of connectivities. Wired, wireless. Wired Again, we have various types. Ethernet wire, which means Ethernet is the standard. Ethernet is the protocol, the LAN protocol. Serial wire, which is a WAN protocol, PPP, HDLC. Fiber optics, FC, fiber channel protocol. Wireless. When we talk about wireless, a lot of radio waves. Radio waves with a different frequency. Different frequency, different protocol name is given. IEEE 802.1a. That is one frequency. 1b is another frequency, another wireless protocol. 1n, that is another frequency. So for communication, for networking, we have wired communication, wireless communication. In wired, we have different technology. For that, we have different protocol, LAN and WAN protocol. Wireless also, we have different frequency, so you have different protocol. IEEE 802.1a, 1b, 1g, 1n, and so on. Right, we are going to see, when we do lab, we will be using some cables where we have Ethernet. You can also have serial wire and have that protocol like HDLC or PPP. I'll show you when we do the lab. So what I'm trying to say is networking composed of many components. One is the connecting media. The other one is the device. We have various type of device. Some devices are like the device that are to connect devices within a network. I repeat, sorry to confuse you like that. You see, we will have different networks. If you have devices in same network, you need a switch. If you have devices in different network, you need a router. See, if you have some computers, (10.0.0.1), this is 10.0.0.2, this is 10.0.0.3. All these three are in same network. Same network. So I need a switch. So this is how we draw a switch. This is how we draw a switch. But if these computers are in different network, let's say I have a computer, 10.0.0.1, I got another computer, 20.0.0.1, and I got another computer, 30.0.0.1. Now, if you want to connect between these three, then definitely we need a router. See, we need a router this time. This is how we draw a router. We put one circle. So, we have various devices in networking. Switch is to connect between the same network device. Router is to connect between the devices that are in different network. So, We are going to learn about devices today. We got various type of devices. We are going to start from the olden day device called amplifier. Amplifier was in the beginning used. It was used very long back to connect between two devices that are far away. Let's say I got a computer here, 10001 IP address A, computer A with IP address this. And I got another computer here with 10002 and the name is B. Let's say this is too far away. So I use the amplifier to amplify the signal because they are too far away from one another, the signal gets weaker as the signal passes through. So the traffic that was sent here with the full strength, what happened is it became weaker, gone. But when you have amplifier here in the middle, what it does is it amplifies so that it can reach the faraway device. Whatever A sent, without amplifier, it is not possible for B to receive. Amplifier amplifies the signal. B is able to receive it. But there is a drawback in this amplifier. The drawback is this. On the way, some noise got added and the noise also now got amplified. What is noise? Noise is the data which you have not sent, which got generated as the traffic goes through the electromagnetic force, earth gravity. The electromagnetic force on the roadside, there may be a big transformer or maybe some electric wire going on, high voltage electric wire. Now, next to that electric wire, if you have this data wire, the disturbance that is caused will create noise, which is unwanted data. Noise is nothing but unwanted data. We got unwanted data. Right? So this noise also now got what? Amplified, magnified. When B receives the data, he is not receiving the actual data. Along with the actual data, some garbage values. Some noise is also seen on B. So what they did, they came up with a filtering device called a repeater. What I'll do is I'll just erase this and I'll draw a repeater. Alright, so when we have a repeater, The noise is filtered. The noise gets filtered. Repeater can identify the original data and the noise and only regenerates only data. It regenerates only data. All the unwanted garbage data is filtered out. Repeaters can do that. Yep. So we have repeater as a better device than amplifier. The purpose is same. I want to communicate to a far away device. A and B are too far away. A wire is not sufficient to carry the data that far. So I introduce repeater. The advantage of repeater or amplifier is repeater only regenerates the data, not the noise. Repeaters comes only with two ports. Two ports. If this is input, then this is output. If this is input, then this is output. Just two ports, port 1, port 2, only two ports. So if you wish to connect the third device, you don't have a port. Only two devices can be in a group. See how small the networking was once upon a time. This is how it was. So what they did is, to connect more devices, they designed multi-port repeater. We call it as hub. Hub is a multi-port repeater. Multi-port repeater. Hub is a multi-port repeater. It is a repeater, but with more ports. Repeater is good, no? It is not sending noise. Hub also filters noise. Difference is this has got more ports. How many? Hub has got 4, 6, up to 8 ports. Up to 8 ports, that is the maximum for a hub. Right? So hub is a multi-port repeater. Hub is also like a repeater which only regenerates data, the original data, by filtering the noise. The advantage of hub over the repeater is hub is multi-port. You can connect more device, but problem is you can't go more than 8. If you say no, I will buy 2 hub. If you say I'll buy 2 hub, this is 8 port, this is another 8 port. I'll connect one wire. So I got 7 port here, 7 port here. And totally I can communicate to 14 device. No, this is not recommended. You can't have like this. If all this 14 communicates at the same time, this hub cannot handle such a large amount of data. Hub cannot handle traffic coming from 14 different devices They are designed maximum to handle traffic from 8. That's the limitation. The design is like that. If you have a bicycle, will you say, I can take 4 people in my bicycle because Enfield Bullet is taking 4 people? Can you say that? You can't say. This also has got 2 wheels, that also has got 2 wheels. So I'll take 4 people in bicycle. Lady bird. Bicycle, lady bird, very thin and slim, and will you be able to take 4 people? One person itself is maximum for that. People like me, the one person, if I go fast, the wheel get bent. Yeah. It's not possible. Though it has got 2 tires and wheels like a bullet bike, though it has got a big wheel like a bike wheel, but the designer won't support 4 people. Same story. Hub is designed only to have 8 devices connected. So you won't have more than 8 ports in a hub. You will have 8 or less than 8. 8 or less than 8. So you will be able to only connect and communicate between 8 devices. That's all. Right? That is a design. What is the design? It is designed like this. It has got only one controller to avoid collision and also to do broadcast. To do broadcast and to avoid collision, there is only one controller. We call it as domain, collision domain and broadcast domain. There is only one domain which is responsible for both collision avoidance and broadcasting. See, sometimes we need to broadcast. Broadcast is what? Sending every data to everyone. For example, if a device that is connected here in this port sends the data, that will go to every device that are connected. Then broadcast is used. Broadcast is the one which carries data to everyone. So what I'm trying to explain here is, if A is talking, B, C, D, E, F, G, H is going to receive. Actually, B wants to talk to D. Actually, this B want to talk to D. But it goes to everyone. The reason is there is only one broadcast domain and only one collision domain. What is one broadcast domain? All are in one group. There is no multiple groups. All are in one group. Because they are all in one group, if anyone say all can hear that because they are in same room. When everyone is in same room, one person sneezing others can hear. But if you put them in different rooms, that is avoided. When one person sneezes in first room, the person in third room, fourth room, they don't hear that much. They don't hear. See, here we don't have rooms. All are in one group only. There is no multiple groups. You can't create more than what is given. Only one group is given. You cannot make it as 5 groups. You cannot say this will form one group. This and this will form one group. And this will form another group. You can't do that. You cannot do that. Only one. Now I think you will understand why there is only 8 port. In one room, if I have 5 babies of 2-month-old, let's say, 5 babies, you may tolerate. See, managing 2 baby itself in one room is difficult. 5, okay, because they pay you good big salary, you manage taking care of that 5 babies. What will happen if you add another 5? You will leave the job and go. I don't want to do this. What we call nanny job. You will leave the job. But if there are 2 separate rooms and 2 different nanny, then we can accommodate like 10 children in that daycare. If there is only one room in the daycare and only one nanny to take care, you cannot enroll more than 5 babies in the daycare. See, because there is only one broadcast domain, you cannot have more than 8. Because the backbone, the motherboard, which is inside this hub, cannot handle. The design is like this. You have only one broadcast domain. There is no multiple rooms. There is a single room. One broadcast domain. One group. All 8 ports are in one group. If I have 9th device, that will also join the same group. Because in hub, you cannot have more than one broadcast domain. If you add another hub, if you are adding another hub, so another 7 devices are going to add. It's like one nanny and one room. Nanny says I can take care of 5 children. But now you are adding another 5 to the nanny. What nanny will do? She will leave the job. That is what will happen in a hub. That is why you should not connect like this. That is what I said. Not recommended to connect one hub to another hub and have more devices. No, it's not recommended. The architecture won't support. The design won't support. And between this 8 device, to avoid collision is what? Data of one device blocking the data of other device. That is collision. To avoid collision also, there is only one controller. Only one controller to avoid collision. only one controller to do broadcast, to take care of that group, broadcast group. Only one controller you have. Only one controller, so you cannot have more than 8 devices. If you have 2 nanny, 2 rooms, you may have double the amount. But problem is, hub don't have 2 nanny, 2 rooms. Hub is designed as per the standard to have only one collision domain and one broadcast domain. So you will not find anywhere in the market more than 8 ports. Only 8 port. Fine, but I want more device. In my company, I'm not just having 8 devices. I have 300 employees working. How can I use hub to connect 300 employees? Not possible. Yeah. So they came up with another device called bridge. Bridge. In bridge, by default, you will have one room, one broadcast domain, but n number of nannies, collision domain. N number of IMA. One room, more IMA to take care of the babies. Meaning, if I have 48 port, let's say this is no, there is no bridge of 48, sorry. If I have, let's say, 25 port bridge, if I have 24 port bridge, all 25 by default will be in one group. But, means all 25 babies are in one room. But the good news is, each babies have got a dedicated nanny, IMA, dedicated caretaker. As a result, you can have more children enrolled in that daycare. You see? What is the difference between bridge and a hub? Hub has got only one collision domain and only one broadcast domain. Bridge has got one broadcast domain by default, but more collision domain. For example, if I have 24 port, then 24 collision domain. If I have 25 port, then 25 collision domain. What is collision? One dashing the other. This is collision domain, collision controller. To prevent one dashing the other, each port has got a controller so that the collision will never occur. As a result, the device can accommodate more than 8 because there is someone to take care of the collision. யாரும் அடிச்சிக்காம பார்த்துக்கிறதுக்கு ஆட்கள் இருக்கிறாங்க. More collision domain. You see? So, bridges can have more device than hub. But again, this is not sufficient because this can only support maximum of 25. The reason is again the design. This one room, no, this one broadcast domain, this one room with the 25 nannies is not an air conditioned room. So babies go very often and smelling too badly, no good air condition. And it is also hot, sunny outside, suffocating inside. Fans are running, but yet sweating is happening. So if you add more children, more than 25, all nannies will leave the job. Two reasons: sweating a lot and smelling very bad. 25 is the maximum. Even though we are one nanny for one child, that room size, no air condition, very hot, smelly, 25 only accommodate. You can accommodate in the daycare. So came what? Bigger room. Okay, 1 minute. So the bigger room device came. Bigger room with more air condition and more number of nannies. We call it a switch. Switches also by default got only one broadcast domain and n collision domain. But the good news is it comes with air condition. In that bridge, that room was not having air condition. The room was small, no exhaust fan, stinky smell. Now a big building has been rented with exhaust fan, air condition, and more nannies are there, so you can have more and more and more and more babies accommodated for the daycare. Yeah. Switches can accommodate more devices, even 300 port switches we have. Yeah, 300 port. Yeah. It is because of the design. I was talking about air condition, no? Here it is not really air conditioned. Here what exactly is, this is hardware based device. Bridge is a software based device. I repeat, bridge is a software based device. Switch is the hardware based device. In switches, no, to handle the incoming traffic and handle the outgoing traffic, you got special hardware components called application centric infrastructure, ASIC chip, integrated circuit, application centric integrated circuit. This is a small tiny chip which is there on every port. That's like a small CPU. See, you already have one big CPU. Apart from that, you have multiple CPUs right on the port, so that this can be more energetic, more efficient to handle more traffic. Whereas in the previous bridge, there is only one CPU which have to take care of everything. In switch, lot of jobs were taken care by this ASIC chip. Very less job comes to the centralized CPU. Because of this more ASIC, we call this as hardware based device. This also got operating system, software, but load is not given too much on the software. Whereas on the bridge, more load is given to software, and the software runs on only one single CPU there. Here there are many CPUs. Apart from the main CPU, you got a lot of ASIC. That's why switches are called as hardware based device. Switches are hardware based device. Bridges are software based device. Bridges can handle only maximum of 25. Switches can handle more. Now both the switch and bridge are smart device. Both bridge and switch are smart device. Why we call it a smart device? Both bridges and switches can learn the MAC address of the connected device. For example, if I have a computer here, and let's say this port number is port number 2. This is port number 1. If I connect this computer with the, let's say the computer's MAC address is BBB, the switch will immediately learn that there is someone called BBB on port number 2. It learns and remembers who is connected where, so that it need not to send a broadcast to everyone. It can send exactly to whomever it need to be sent. See, when will the broadcast happen? When the destination is not known. Hub never learns MAC address. See, the amplifier, repeater and hub that we learned. Amplifier, repeater and the hub that we learned, they never learn MAC address, so they always flood. They always broadcast. Whereas the bridge and the switch, they learn the MAC address of connected device. As a result, bridge and switch knows who is connected where. And if a traffic wants to go to BBB from, let's say there is a computer here called YYY. If a packet needs to go from YYY to BBB, it won't go to everyone. It will go exactly to that port where BBB is connected. That is why switches and bridges are called a smart device, intelligent device. Intelligent device. Hub is not an intelligent device. Hub is not an intelligent device. Bridge is intelligent. Is it true? Yes. Bridge is an intelligent device. Switch is an intelligent device. A repeater? No. Repeater never learns MAC address. Hub never learns MAC address. Now, what is the similarity between switch and a bridge? What is the similarity between switch and a bridge? They both learn MAC address. Secondly, every port has got one collision domain. Third, both by default have got only one broadcast domain. And what is the difference between this and that? Switch is the hardware based device because it has got additional hardware components called ASIC. Bridge, even though it is a hardware device, we don't call it as a hardware based device because the software that is running on the bridge does all the operation. So that's a software based device. Look wise, both switch and bridge look similar. Metal box. But here you got more CPUs, ASIC hardwares. There you got only motherboard, one CPU, and some buffers and operating system. Here you got additionally more hardware. See, this is one of the questions that you can expect in interviews. What is the difference between bridge and a switch? Bridge is the hardware based, bridge is a software based device. Switch is the hardware based device. In OSI layer, we'll be learning about OSI layer in our next class. In OSI layer, switch and bridge works in same layer, and that layer is called as layer 2, data link layer. In this data link layer, both bridge and switch works. Whereas in layer 1, we have hub, repeater and amplifier. Hub, repeater and amplifier is layer 1 device. Bridge and switch are layer 2 device. Did you understand all that I have said? That's great to hear. So I'll stop here. We'll meet tomorrow.